problem where you have the same base numbers or base letters, in this case the same base variables. What do we do with the powers? Add them together. So in order to add these together, they have to have the same denominator. Well, if they got the same denominator already, all you have to do is add them together. So what would this be? Y to what power?
12
Okay,
over 3,
5.
4.
So you add the top numbers together. The denominator stays 3, right? Okay, now tell me this. Y to the 12th over 3 reduces down to 4. So you would have y to the 4th power. Right? Okay, now everybody go to number 37. Okay. We're going to do the odds here for a second. So number 37. A to the negative 2/3 over a to the...
Are you doing number
Whoops, wrong one. So what's the difference now between where we had numbers on the same, right, the same level, and now we have a power raised by another power? So if you have a power raised by a power, what do? Yeah, this time we multiply instead of adding, and so this is very simple to just multiply straight across, top and bottom. Now, as long as you have a 3 bottom and a 3 top, you can reduce those down by 1, and that will leave you b to the 1/5 power.
Wait, whoa. How do we do that? Isn't it if the light's on?
If I ask you to write this, right here, if I ask you to write it in radical form, what would it look like in radical form? Remember flower power. So the 5 does what?
Square root 5
Goes over.
Okay, so it's root 5 or index 5.
b to the first power, which is just b.
Just b, because we don't really need to put a 1, do we? B to the first is the same b. All right, has everybody got that? Okay, so if you have a variable raised to a negative power, we just go downstairs with it. So it would be w to the positive 4/5, and you have to leave a 1 on top. We always have to leave something out there. You can't just leave it blank. Now, because this has a variable in the bottom, it has a power in the bottom that is a fraction, you can't have fractions. One of the rules is we need to get rid of this, so we have to match it up. I don't know if you guys remember how we match these up, but if I could make this into something that was 5 over 5, yeah, so if you multiplied it by 1/5, 1/5 and 4/5 makes 5. Add those together, you get 5/5.
Oh, wait.
And
Did
you
we
get
just
1.
throw that in there just because?
Yes, because this was 4/5, and we needed to make it into 5/5.
I don't
Wait,
like
does
it.
that say 4 or 5?
Just like Kansas City.
Yeah, you
It's
pull that in like...
recording.
This right here. If you had the square root of x equals 4, just watch, okay? So you have the square root of x equals 4. What is the opposite of a square? Or square root, excuse me. What is the opposite of a square root? A square. So if I want to get rid of a square root, I square it. Whatever you do to one side, you do to the other side. All right. Squares and square roots cancel each other out, and then you multiply 4 to the 2nd power, which is 16. When you're doing these problems, always make sure you double check that your answer will actually work. So you need to plug that back in and take the square root of 16. Is the square root of 16, is it really 4? Is the square root of 16 4?
Yeah.
Yes. So this works. So this is true. All right. And that's how you would solve it. So the basic idea here is to make sure you isolate the square root all by itself so that you can square it. And once you square it, once you square that, then it'll get rid of it. So if you want to get rid of the square root, you square it. All right? Square it and square it. Okay. Now, let's say you had a problem like this one right here. Let's say you had the square root of x minus 3 equals 1.
So we have to somehow square the...
Okay, yeah, you just, because this is just a square root on one side, of all of this is a square root, you can just square this and square this, and that will get rid of the square root so that you're left with just that.
Equals
Okay.
1.
And then it'll equal 1 times 1 is 1. Then you add 3 to both sides, so x is equal to 4. Now, take your answer, 4, make sure you go back to your original problem, so you're going to plug the 4 back in. 4 minus 3 is 1. The square root of 1 is, since the square root of 1 equals 1, then that is a solution. Now, sometimes you're going to get answers that when you plug it back in, they won't work. And then you just have to write no solution. Okay, those will be no solution on some.
One more.
If the answer, when you plug it back in, does not work, you get no solution. All right. I want to show you one more here where that happens. If you had 1 plus the square root of x plus 2 equals 0, you're going to remember I told you, you have to isolate the square root by itself. So I need to get rid of this 1. How do I do that? Minus 1, minus 1. That will leave you, this right here is just going to make 0, so it's gone. You don't need to worry about it. Square root of x plus 2 equals negative 1. Now, get rid of the square. I can square root, but think about this for just a second before you do this. Is there any way, okay, don't have to reteach this. Is there any way I can plug a number in here? Is there any way I can plug a number in here and add it to 2 and get negative 1 when I square root it? What happens when you try to square root a number? Do you ever get a negative number when you square root something? No, that's impossible. Matter of fact, your calculator will say error. And so, if you go ahead and try to solve this, you square both sides, you're going to get x plus 2 equals 1. Then I minus 2 from both sides, and I get x equals negative 1. If you try to plug negative 1 back in here, but let's go back to our original problem. Go back to the original one up here. We're going to plug in negative 1. Okay, so this would give you 1 plus square root negative 1 plus 2. Does that equal 0? Notice that you're going to get 1 plus square root of 1, which is 1 plus 1. That's 2 equals 0. True or false?
No.
True or false? You guys, hey, pay attention.
It's false.
Yeah, so since it's false, you know this is
No solution.
no solution. All right? No solution.